You guys have not learned how to sketch the graph of each function, but you should be able to know any asymptotes or holes in the graph. So you've been learning the past couple days to basically figure out, is it factored? Class, yes or no, is this factored? Yeah, I can't factor it. There is no greatest common factor, and there is no trinomial, A, B, and C, and I don't have to use the X box. Class, is this one factored? Yeah, so I don't have to do anything to it. So I've already completed step number 1. Class, can I cancel anything? Yeah. Remember, whatever I cancel, class, that's called a removable hole. So I like to draw boxes, and then in here I'm going to say this is my removable hole. And what did I just cancel out? X squared. We're going to set it equal to 0. Essentially, the removable hole and the vertical asymptotes are your restrictions on the domain, so you could also write not equals to. Okay, this is where some students struggled majorly in the last test. To get rid of the power of 2, you have to do what? Okay, now if I take the square root, there is a plus and a minus. But class, is there ever a positive 0? Is there ever a negative 0? No. So my removable hole will be at x is not equal to 0. And then the only thing I have left, so let's highlight this in a color. Let's go ahead and highlight or box what is not canceled. The only thing I didn't cancel here is y equals 2. That's my equation. Class, is there any variables in this pink box? No. So it's not linear, it's not quadratic, it's not exponential. That means it must be a constant. Okay? In today's lesson, we talked about, so there is no vertical asymptote. Let's talk about this new idea of finding the horizontal asymptote. Put your finger on the degree of the original problem on the top. The original degree is a 2. So let's work this out. Horizontal asymptote is a 2. Put your pencil or finger on the bottom degree or exponent. What number is that? It's also a 2. And what do you notice about those numbers if you had to put an inequality? They are equal. If they are equal, then what we're going to do is we just reduce that, which means that if I cancel this out, we're going to see something happen at 2. Okay? Okay, so we have a bunch of puzzle pieces here. I have something about the horizontal asymptote. I have a removable hole, possibly, but I also look at my graph. We already looked to see if there's any vertical asymptotes or points of discontinuities. Now we're going to draw our vertical asymptotes, which we didn't have any. You can make a table of values, so let's make a table of values. Class, do you see any, in the pink box, do you see a variable x? No, so you can't put a number x into there because there's nothing to put it into. But it's telling me all of my y values are what? 2. That means you can make up x values. 0, 1, 2. Alright, let's put this all together. I have a removable hole at 0. This essentially is at the x value at 0. So I'm going to draw this little red line. I don't know if you can see that. But that's where it's going to be the removable hole. If I graph this, 0, 2, 1, 2, and 2, 2, then my graph is actually just a horizontal line. And remember, we learned that where this, not the vertical asymptote, but where it intersects the graph, that's where my donut hole is. So in this equation, it's just a horizontal line, and then it's undefined at 0, because if I put in 0 here, I get 0 squared. Anything divided by 0, class, is? Anything divided by 0 is? Undefined. Remember, no, right? Anything divided by 0 is undefined, not 0. That's why there's an open circle. This is defined, this is defined, this is an order pair, 2, 2. That's defined. This is undefined.